Hello viewers, today in this topic we will discuss about array and its application, operations, and how we declare array in a program code. Okay, so let's start. So suppose this is an array. This is what an array looks like. Okay, and these are the indexes of array by which we can access its element. Okay, this is the 0th index, this is the first index, this is the second index, this is the third index, and this is the fourth index. This array is of size 5. Its size is 5. Okay, so what is an array's definition? An array is a finite ordered homogeneous. Okay, why we call it an finite? It is because an array can contain only a finite, only a limited number of elements. Okay, suppose take this example. We can store only 5 elements in it, not more than that. Okay, so, and ordered, what is ordered? This an array stores elements in a contiguous manner in the memory location. See, one after the other. Okay, and homogeneous, what is homogeneous? Suppose take an example. This is an integer type array. Okay, integer type array. Then this array will store only the integer type element only, not float type, not double type, not character type, not anything else. What I mean to say, if 0th index contain 5, we cannot store in the first index a or 5.0. This would mean float. Okay, and a will be character element, so we cannot store. If this is an integer, if we declare an integer array, we have to store integer element only. Okay, that is why it is called homogeneous. This is the definition of array. Now what is the application of array? Why we use array? Okay, number first applications, we can use array for searching an element. Suppose uh, if we want to search 12, if we want to search 12, then the output will be index 2. Okay, index 2 will be the output if we want to search 2. Okay, if we want to search 12, sorry. Number second application, sorting. We can use array for sorting purpose, for different sorting purposes. Okay, what is sorting? We can arrange the elements in either descending or ascending order based on different sorting method. Okay, number 3, an array is a home of stack. Okay, now what do you understand by home of stack? Oh, home of stack and queue, sorry, both. Okay, stack and queue. Why we say so? It's because we can implement stack and queue by array also. Okay, both stack and queue can be implemented by array. That's why we call it home of stack. Okay, number 5th application is it can be, sorry, number 4. It can be used to represent non-linear data structure. Okay, it is also very important. An array can be used to represent non-linear data structure also. What are some non-linear data structure? I discussed in the previous video. Non-linear data structure means tree, graph, like that. Okay, So these are the applications, few applications, there can be many. Okay, now what are the uh, operations on array? Writing here. Okay, operations on array. What operation can be done in an array? Number first, we can insert element, insertion can be done. Okay, number second, deletion can be performed in an array. Suppose suppose let us consider this element is not present in fourth index. Okay, suppose we want to insert in the fourth index, we can insert 15 or any number in the fourth index or any other index. Okay, that doesn't matter. We can perform deletion in an array. Suppose we want to delete number 12 first, but very important, for deletion we have to search where that element is present we want to delete, then we have to delete that element. That means first, if we want to delete 12, we have to first search for where 12 element is present, that is index 2, here it is present. Then we have to shift element from the right to its left. Okay, that means this array will looks like this: 5, 10, 13, 15. See, 12 is deleted. Now the element to its right is shifted to its left. Okay, one by one to till the last element. Okay, so and another applications is there, traversing. Sorry, another operation, sorry, not application. Operation is traversing is very easy. Traversing means from 0th index to the last of the to the last element of the array, we will traverse each element, we will visit each element. Okay, that is called traversing. I will make a separate video on these operations. Okay, in my next video I will make a separate video on this. Okay, now how this an array is represented in a memory. Okay, if we consider an array can be multi-dimensional or single dimensional. See, this is a single dimensional array. Okay, multi-dimensional will look suppose if we consider 2D array, that is a multi-dimensional array, and it is a 1D array. Okay, let it be here, single dimension array, single dimensional array. Okay, how it is represented in the main memory. Okay, let us consider, this single dimensional array. First index 0, 1, 2, 3, 4. Okay, this is, suppose 0th index, the address of this 0th index is 1000. Suppose let it be, and this is the base address. Okay, this is the base address. The first 0th index address is called the base address, and if we store integer type variable, then the weight of that element is 2 byte. If we consider float type element, then it will be 4 byte. Okay, so how the address calculation is done for single dimensional array? If we let's think 5, 6, 10, 12, 15. If we want to if we want to calculate the address of element 10, how it will be done? 10 is present in 2th index. Okay, so we will consider the first the base. Okay, plus sorry, this will be I. Okay, I means the index where the element is present. Okay, this will be I minus L into W. What is W? W is a weight, that is here it is an integer type array, that's why it will be 2. Okay, if it is a float, then it will be 4. And what is L? The lower bound of an array. If nothing is given in the question, then always consider 0 as the lower bound. If it is given, then it is fine, you will put that. Okay, I is what? I is 2 here. Okay, so so address of 10 will be 1000 plus I will be 2 minus L will be 0 here. Okay, 0, here the lower bound is 0, and into W is 2. Okay, so sorry, this will be 1000. Okay, 1000 plus 4, it will be 1004. Okay, this 1000 is not exactly the address, I just considered for simplicity purpose. Okay, 1000. And if we the address calculation for multi-dimensional array is to be done, then it can be performed in two ways. One, row measure, and another is column measure wise. Okay, so how I will rub this part. So this is the formula for column measure order address calculation for 2D array. Okay, this is a row measure method or formula for address calculation. Suppose we take an example for m. M is sorry, I have not written m. M is number of row. Okay, m is number of row. Suppose we take let us consider number of column to be 3, number of row to be 3 also. Okay, we take 3 cross 3 matrix. Okay, 3 cross 3 matrix, and we take base address as 8000. Let us check out what happened. So in column measure order, it will be A of what we want to find out. A of A of 2, 3. We want to find out the location of A of 2, 3. Okay, so base address is 8000. 8000 plus weight, we are considering integer type array, so it will be 2 cross now m is, what is m? M is 3 into 3 minus 1 plus 2 minus 1. Okay, this happens. If you calculate, you will get 80014. Okay, now address in memory is always in hexadecimal form, so 14 will be 800E. Okay, understood? Because address is always in hexadecimal form. Same if we do the address calculation in row measure order, what will happen? Let us see. 2, 3. Okay, now base address is 8000. Okay, and W is 2, N is 3, J is 2, right? Wait a minute. Yeah, J is 2 minus 1 plus K is, what is K? Column number. Achha, K is 3. Okay, now if you calculate this one, you will get 800 base address plus this will be 10. This will be 10, that means A in hexadecimal form. So 800A. Okay, this is how two-dimensional array address calculation is done. Now you may have a question: why do we need row measure and column measure order? Why do we need? Because array is a ordered collection of data. Ordered collection means one after the other. But in two-dimensional, we have multiple rows and multiple columns, right? That's why we need this format. This format is needed. That is why row measure and column measure order is important for this order for which we want to get this order. Okay. Now, how to declare an array? You can take a screenshot of this part. Okay. Now, how to declare an array? How to declare an array? It is very simple. We can declare an array in two types. One is static declaration. One is static declaration. In this case, the size of the array will be fixed and cannot be altered in during the runtime of the program. Okay. And another is dynamic allocation, dynamic declaration. Sorry. Dynamic declaration or dynamic memory allocation, we can call it. In case of static declaration, what we need to do for declaring an array? Suppose we are declaring an integer array. Okay, we will simply int data type, array name. We are considering here ARR for array. Okay, ARR and size. What do we want to give the size? Let us consider this as size. Okay, later you will take the input of size. Here I am writing the size equals to 5. Okay, this array will get declared. Okay, this is a static declaration of array. This size will not get altered during the runtime of the program. This is fixed. During the dynamic allocation and the dynamic declaration, what do? We use pointer. Okay, we are considering int type pointer. This is a pointer. Now this pointer is used to point the base address of an array. Int, this is a typecast. Okay, int star cross malloc. You can use malloc or calloc. Okay, malloc size. What you suppose we are considering here 5. The size of the array we want to take is 5. 5 into size of int. Why we are writing size of int, not 2? It depends on different operating system. It is 2 or 4. That is why we don't take chances. We write size of int directly. Okay, it is we are taking giving the responsibility to the computer to calculate. Okay, this is the process. Now we can use this as calloc. I'm writing here. We can use calloc also. Okay, using calloc function we'll do this. When we declare an array, all the indexes will be stored initially by 0. Okay, initially all the indexes will be stored as 0, but in malloc function it remains empty. Okay, what is the usefulness or what is the advantage of using dynamic declaration of an array? We can alter the size of array during the runtime for the program. Okay, how we can? By using realloc function. Okay, we can alter the size of the array according to our wishes, our needs. Okay, so this is array. Okay, this is our today's video. If you have liked our video, please like, share and comment down your what video next I should make and please subscribe our channel to and press the bell icon to get notified. Thank you.